Hello everyone, welcome to another problem session. So, and in this, we are trying to go through the problems that was in 2024 JEE Advanced Physics Paper 1 right now. We're going to do Paper 2, 1. So we're done with Paper 1. And this is in India. Okay, so let me read this problem. This is actually a pretty simple problem, but let's go through it. So we have a point source S, and it kind of emits this unpolarized light in every direction. So and there are 2 points. We have point A here and we have point B here. So if you a light goes, a bunch of light goes in that direction. So if you look at the intensity here, you can call it intensity A, and say this distance is R A, and from here to here is RB, and the intensity is IB. So we are told that the IB over IA over IB, which is defined to be the ratio R. This is 2. And why is that important? Well, intensity intensity is energy crossing per unit time per unit area, right? So if you think about, you can think about all this a sphere at the center is the source, and another sphere center is source. So all the energy crossing this sphere must cross this sphere because there's no energy is accumulating. So you can say IA, let me write down, you can say IA times 4 pi RA square is that's the amount of energy, this is the area of this this surface, okay, must equal IB times 4 pi RB square. So this IA over IB, this ratio IA over IB is actually RB square over IA square. So this tells you about the distance relationship between them. So this is RB square over RA square. All right, so that's one thing, but actually this is not necessary for you to know to solve this problem. It's just something that when the ratio comes up, you should know. Maybe it will be helpful in some other problem, but here is not the concern. Okay, so next part of the question is if a set of 2 polarites just before point B. So let's say at around point B. So this is 90 degrees to that. So one Polaroid is maybe this is the passing direction. So when it comes out, light is polarized that way, and just before this, and then over there, at the same point, let's say these two are very close to each other, so we don't have to worry about this distance business. And this one, so this was where the green one is coming in, but for this, the passing axis is that. So if you know the intensity, say let's call it both of these as IB1 and IB2 is just before B, so we're just going to call it both of them B's. Okay, so the light that's coming in over here, let's call that, because it's also let's call it just IB, all IB0. So IB0 is equal to IB, okay? But when it goes through the polarizer, this intensity will become half, because you have two polarized direction, half goes this way energy, half in that way energy. So IB, at this point, let's call this point C. At point C, when let's go into polarizer 1 and polarizer 2. Let's call those names instead of I's. So I see that right in the middle between these two polarizers is actually half of IB0, which is half of IB. And then when it goes through the second one, then in terms of the angle, so if this is polarizer incoming and this is the direction the outgoing, the second polarizer is polarizer 1 and this is polarizer 2 and this is theta, then the intensities, of course the electric field of the out is related with electric field of the in, and the projection, suppose electric field this way, the project over there, so that's going to be E cosine theta. So intensity is proportional to the electric field square. So you can see the intensity out will be cosine square theta intensity in. So this is basically what the question is about. If you understand this, then we can just apply it here. So at IC is half IB, and then the one through the polarizer, we're just going to get IB, let's B prime, is just, let's call this B prime, IB prime, that which will be the new IB, equals to new IB after two polarizers, right? That will be IC times cosine square 45 degrees, which will be half. This was actually, I wish they had done something a little different, some other angle. You know, I would have placed maybe 30 degrees or something like that, or 60 degrees. That will be IC times half, and IC is half IB, so this is half IB times half equals 1/4 IB. So the new IB prime is a quarter of the old IB. So now we can just use this to relate with IA over new IB prime. This is the new with the polarization in between, is equal to, so we have a IA over IB, and I have IB over IB prime. So I over IB was 2, and IB over IB prime, from here IB over IB prime is going to be 4. So it's 4. So this will be, the ratio will be 8, and that will be the answer. Okay, so having solved this problem, I always like to go back and see what was a couple of things that happened. So I would reiterate that when you have a polarizer and analyzer, so this P1 here is called, let me kind of pause and erase some of this. Okay, so I clean up some of the stuff. So if you you have this is the polarizer, because before this it's unpolarized. When the light comes out here, it's polarized that way. That was the point CR in this previous pictures. And so when it comes in here, and this guy's angle is the path direction is that, and electric field is that way. So we have to get the electric field projected. It is coming in this way, and I have to project it that way. So we need that. So this angle theta. So if the electric field is E here, E in, so you can see that E out will be E in cosine theta. So that's what I read it over there. So when you get to the analyzer, you are going to have intensity out will be intensity in times cosine square theta. And that happens because intensity is proportional to electric field square. I think this is, once you know this, you can completely trace through that. And the place that you want to study is called Malus's law. And if you look at many places, even in my book, at this website, you can go and study more about physicsbootcamp.org. So this you can go study more on this that place, or your textbook. Okay, so this is for now. So I'll see you in another video. Bye.